Chapter 15, Statistical Quality Control. Okay, and we are going to talk a little bit about TQM, also known as Total Quality Management. But our focus is going to be on statistical process control and the control charts for variables and attributes. So we'll start with TQM. So quality is a management decision, or it's not just quality control, but quality management should come from top down, and it should be pervasive throughout the organization in every step of the way. Now, statistical process control is a tool that is used to improve and sustain and maintain quality, but it is only a tool. But total quality is a much broader concept in bringing quality in every aspect of the operations of a company. Okay. Now, you can define quality in terms of many different aspects of the product or the service. Okay, the defining quality itself is not an easy task, but fundamentally the idea is to meet and exceed the expectations of customers. Yeah. And the total quality management refers to a management perspective to achieve and maintain that, achieve and exceed customer expectations. Yeah. And here is several ways of defining quality, and there have been different people who have had taken a lead role in emphasizing quality and making quality part of everyday operations. And there is some important persons, Duran and Baldrige, and these are individuals who contributed a lot to make quality a priority. Yeah, now, statistical process control, which is going to be the focus of this chapter, it is about taking samples from the production process and coming up with control mechanisms such that if the process goes awry, then you can detect that automatically and stop the process and investigate and see what's wrong. So statistical process control is about monitoring a production process statistically. Okay, and then if there is an anomaly, if there is a statistical anomaly, then you are able to then stop and intervene. So that's the whole idea of statistical process control. And that is based on the concept that the process is inherently variable, in the sense that any process, any production process, okay, is going to have some kind of variability in the production process. Okay, and that is unavoidable. So as a matter of fact, it is so unavoidable that if a particular measurement that you take repeatedly, if it stays exactly the same, it's more than likely that the instrumentation is the problem. It may be stuck or something, not that the production process is so unvariable that it is maintaining exactly the same value again and again repeatedly. So the underlying concept is there is going to be some variability. Okay? And the idea is, if you observe the production process and you see the variabilities, and are these variabilities consistent with what is natural, unavoidable variability, or are there some variabilities that are due to process malfunction or intervention that caused some kind of problem or some anomaly here or there, some defective part? In other words, are the variations natural variations that are unavoidable? Okay, and they call that natural variation or common cause variation, or are there variations that are due to special circumstances that can be remedied? So our idea is to differentiate between common cause variation and special causes variation. So if there are special cause variation, then we can intervene and remedy the situation. That's the idea of statistical process control. Okay, so for this, we need to build control charts such that we capture only the natural variabilities. Okay, so how do you do that? Okay, so here are some examples of natural variation. So we'll come to how to build it in just a second. Okay, so almost all production processes are expected to have some variability, random and uncontrollable, which is what I discussed just a minute ago. So when the distributions of this is normal common cause variability, then it will have two parameters. There is mean, which is the central tendency of the process, and then there is standard deviation, which is standard deviation measures the degree of variability around that mean. And assignable causes are the ones that are not in, when a process is not in control. So here one more concept that you need to understand is that if the process has only natural variations or common cause variations, then that process is said to be in control. Okay? And if a process has, in addition to natural causes, some assignable causes, okay, special causes assignable to some issue with the production process, then such a process is said to be not in control. A process not in control needs intervention. Okay? So control charts help us identify whether a process is in control, meaning there is only natural variability, or whether the process is not in control, which means that we detect some assignable cause that needs to be fixed. Okay.